Rain. Water evaporates from oceans, lakes, and rivers, rises as invisible vapor, then cools and forms droplets in clouds. When droplets grow heavy enough, gravity pulls them down as rain. Light drizzle feels gentle. Heavy downpours can flood streets in minutes. Acid rain forms when pollution mixes with water vapor, damaging buildings and plants. Modern weather radar tracks rain bands, helping farmers plan crops and cities prepare storm drains. Snow. When temperatures drop below freezing, water vapor skips the liquid phase and crystallizes directly into ice. Each snowflake has a unique, six-sided pattern based on temperature and humidity. Powder snow is light and fluffy. Wet snow packs easily but weighs more. Blizzards combine heavy snow with strong winds, creating whiteout conditions. Cities use salt and plows to clear roads, but too much salt can harm plants and groundwater. Hail. Ice balls form when strong updrafts and thunderstorms carry raindrops high into freezing air. The drops freeze, fall, get caught in updrafts again, and add more ice layers. This cycle repeats until the hailstones become too heavy to lift. Small hail feels like ice pellets. Large hail can dent cars and shatter windows. Hailstorms typically last only minutes, but can cause millions in damage. Storm chasers track supercells that produce the biggest hailstones. Lightning. Electric charges build up in storm clouds as ice particles collide. Negative charges gather at the cloud bottom, while positive charges collect on the ground below. When the difference becomes too great, electricity jumps the gap as lightning. Thunder is the sound of air rapidly heating and expanding. Lightning can strike the same place twice and often hits tall objects like trees and buildings. Lightning rods safely direct the electricity into the ground. Tornadoes. When warm, moist air meets cool, dry air, the boundary creates rotating columns of air. If this rotation extends from a thunderstorm cloud to the ground, it becomes a tornado. Wind speeds inside can exceed 300 miles per hour, turning debris into deadly projectiles. The enhanced Fujita scale rates tornadoes from EF0 to EF5 based on damage. Tornado Alley in the central United States sees the most activity due to geography and climate patterns. Hurricanes. These massive storms form over warm ocean waters where temperatures exceed 80 degrees Fahrenheit. Rising warm air creates low pressure, and the Earth's rotation makes the system spin. As the storm feeds on warm water, it grows stronger. The eye is the calm center, surrounded by the violent eye wall with the strongest winds. Categories range from 1 to 5 based on wind speed. Storm surge often causes more damage than wind, pushing ocean water far inland. Fog. Fog is simply a cloud at ground level. It forms when water vapor condenses into tiny droplets suspended in air. Radiation fog develops on clear, cool nights when heat escapes to space. Advection fog occurs when warm air moves over cooler surfaces. Sea fog forms when warm air passes over cold ocean water. Dense fog can reduce visibility to just a few feet, making driving dangerous. Fog machines create artificial fog using glycol or dry ice. Drought, extended periods without adequate rainfall, create drought conditions. Soil moisture drops, reservoirs shrink, and plants wilt. Agricultural droughts affect crop yields. Meteorological droughts measure rainfall deficits. Hydrological droughts impact water supplies. El Niño and La Niña cycles can trigger droughts across continents. Farmers use drought-resistant crops and drip irrigation to conserve water. Cities implement water restrictions and recycling programs during severe droughts. Blizzards. Blizzards combine heavy snowfall with sustained winds of at least 35 miles per hour for 3 hours or more. Visibility drops below a quarter mile as snow swirls through the air. Ground blizzards happen when strong winds lift existing snow off the ground. Wind chill makes temperatures feel much colder than they actually are. Whiteout conditions make travel extremely dangerous. Emergency kits should include food, water, blankets, and flashlights. Dust storms. also called haboobs. These walls of dust form when thunderstorm downdrafts hit dry ground and pick up loose soil. The dust cloud can tower miles high and stretch for hundreds of miles. Visibility drops to zero, and breathing becomes difficult. Dust storms are common in arid regions like the American Southwest and North Africa. They can carry dust across oceans and affect air quality thousands of miles away. Dust masks and sealed buildings provide protection. Ice storms. Freezing rain creates ice storms when warm air sits above a layer of cold air near the ground. Rain starts as snow, melts in the warm layer, then refreezes on contact with cold surfaces. Just a quarter-inch of ice can snap tree branches and power lines. Roads become skating rinks, making travel nearly impossible. The weight of ice can collapse roofs and towers. Dicing equipment and sand help restore transportation after ice storms pass. Waterspouts. These spinning columns of water and air form over warm water surfaces. Fair-weather waterspouts are generally weak and short-lived. Tornadic waterspouts are essentially tornadoes that form over water and can be much more dangerous. They can move onto land and become tornadoes. Waterspouts are common in the Florida Keys and Great Lakes region. Boaters should head to shore immediately when waterspouts are spotted, as they can capsize vessels. Microbursts. These sudden, intense downdrafts spread out when they hit the ground, creating dangerous wind shear. Wet microbursts accompany heavy rain. Dry microbursts occur in arid regions with little precipitation reaching the ground. Wind speeds can exceed 100 miles per hour, posing serious threats to aircraft during takeoff and landing. Damage patterns show a starburst effect radiating outward from the impact point. Doppler radar helps meteorologists detect microbursts and issue warnings. Aurora. The northern and southern lights occur when solar particles interact with Earth's magnetic field and atmosphere. Charged particles from the sun follow magnetic field lines toward the poles, where they collide with oxygen and nitrogen molecules. These collisions create the dancing curtains of green, red, and blue light. Solar storms can make auroras visible much farther from the poles than usual. The best viewing happens during dark, clear nights away from city lights. Temperature inversions. Normally, temperature decreases with altitude, but inversions flip this pattern. Cool air gets trapped beneath warm air, preventing vertical mixing. This traps pollution near the ground, creating smog and poor air quality. Valley locations are especially prone to inversions during calm, clear nights. Cities like Los Angeles and Salt Lake City struggle with inversion-related air pollution. Strong winds or weather fronts can break inversions and clear the air. Thanks for watching this video. Got some ideas for upcoming videos? Let me know in the comments down below. Also, be sure to like, subscribe, and hit the bell. It really helps pushing the videos out.